Write the trigonometric expressions in terms of sine and cosine, then simplify. So for number 1, part A, we write cosine of t times tangent of t. Tangent of t is equal to sine of t divided by cosine of t. Next, the cosines cancel out, so we're left with sine of t. The next problem is written as secant of x divided by cosecant of x. Secant of x is equal to 1 over cosine x. We're dividing that by cosecant of x, which is equal to 1 divided by sine of x. So now we have 1 cosine of x times sine of x. Whenever you're dividing by a fraction, you multiply by its reciprocal. So instead of dividing by 1 over sine of x, we're going to multiply by sine of x over 1. So now we have sine of x divided by cosine of x, and that equals tangent x. Number 2 says to simplify the trigonometric expression 1 plus cosecant of x divided by cosine of x plus cotangent of x. So the first step is to write out the problem. Next, we convert everything in terms of sine and cosine. So again, cosecant of x is equal to 1 over sine of x we divide that by cosine of x plus cotangent of x is equal to cosine of x divided by sine of x. Next, in the numerator, we're going to multiply sine of x over sine of x to the 1 and add that to the 1 over sine of x. Then in the denominator, we're going to multiply cosine of x times sine of x over sine of x and add that to cosine of x over sine of x. Next, we're going to simplify. Sine of x plus 1 divided by sine of x. Then we're going to divide that by cosine of x sine of x plus cosine of x, all divided by sine of x. So again, when we're dividing by a fraction, we multiply by its reciprocal. So we take sine of x plus 1 divided by sine of x, and we multiply that by sine of x divided by cosine of x times sine of x plus cosine of x. So the sines of x cancel out, and we are left with sine of x plus 1 divided by cosine of x times sine of x plus cosine of x. Next, we simplify by factoring the denominator. So we can factor out a cosine of x to both terms in the denominator. So cosine of x times sine of x divided by cosine of x, we're just left with sine of x here. And then cosine of x divided by cosine of x is equal to 1. So now we have sine of x plus 1 canceling out with sine of x plus 1 here. So we are left with 1 over cosine of x. And the final answer is secant of x. Three A says to verify the identity for each. So we have tangent y divided by cosecant y equal to secant y minus cosine y. Sine of y divided by cosine of y is equal to tangent of y, and that is divided by 1 over sine of y, which is equal to the cosecant y. Next, again, when we divide by a fraction, we can then multiply by its reciprocal. So now we have sine of y So now we have sine of y squared divided by cosine of y. Again, we're trying to verify that this expression is equal to secant of y minus cosine of y. So the next thing that we need to look at is the identity of sine squared y plus cosine squared y equals 1. So let's solve this for sine squared y. We can subtract cosine squared y from both sides. And we're left with sine squared y equals 1 minus cosine squared y. So let's go back and substitute that into the expression here. So we have 1 minus cosine squared y, all divided by cosine y. Next, we're going to split that up. So we have 1 over cosine of y minus cosine squared y divided by cosine of y. 1 over cosine of y is equal to secant y, and cosine squared y divided by cosine y is equal to cosine y. So this is how we just verified that tangent of y divided by cosecant of y is equal to secant of y minus cosine of y. Next, we're asked to verify that cotangent of x times secant of x, all divided by cosecant of x, is equal to 1. So let's write the problem. The first step after that is to write everything in terms of sine and cosine. So cotangent of x is equal to cosine of x divided by sine of x. Secant of x is equal to 1 over cosine x. And then we're dividing the whole thing by cosecant of x, which is equal to 1 over sine of x. Next, we simplify. Cosine of x divided by sine of x the cosines here cancel out, and so we are left with 1 over sine of x divided by 1 over sine of x. Again, whenever we are dividing by a fraction, we can multiply by its reciprocal. Sine of x cancels out, so we are left with 1. Use the law of sine to find the indicated angle. So we know that the law of sine says that sine of angle A divided by side A is equal to sine of angle B divided by side B. Angle A is equal to 120 degrees. Side A is equal to 45 centimeters. Side, or angle B is what we're trying to find, so we'll just write theta here. And side B is equal to 36. The next step is to cross multiply. (36) times sine of 120, all divided by 45, is equal to sine of theta. Next, we simplify. (4 over 5 times sine of 120 is equal to sine of theta. Four divided by 5 times the sine of 20. Sine of 20 is equal to the square root of 3 over 2. Here we have 2 over 5. Times the square root of 3 is equal to sine of theta. So the next step is to take the inverse sine of 2 divided by 5 times the square root of 3. And that equals theta. Therefore, theta is approximately 43.9 degrees. Number 5 says to solve the triangle using side B equals 60, side C equals 30, and angle A equals 70 degrees. So We know from the law of cosines that side A squared is equal to B squared plus C squared minus 2 times B times C times the cosine of angle A. So now we substitute. B squared would be 60 squared plus 30 squared minus 2 times 60 times 30 times cosine of 70 degrees. Two times 60 times 30 times cosine of 70 is approximately 1,231.7. Next, we combine all of our constants. This is approximately 3,268.7. To find A, we take the square root of both sides. A is equal to approximately 57.2. Now that we have A, we can use the law of sines to find angle B and angle C. So we know that the law of sines states that sine of angle A divided by side A is equal to the sine of angle B divided by side B, which is equal to the sine of angle C divided by side C. So now we just substitute. Sine of 70 over 57.2 is equal to the sine of angle B over 60 and the sine of angle C over 30. $60 times the sine of 70, all divided by 57.2 is equal to the sine of B. To find B, we just take the inverse sine of 60 times sine of 70 all over 57.2. That will give us angle B. To find angle C, we would take the inverse sine, or let's take a step back. To find angle C, we would do 30 times sine of 70 divided by 57.2. Set that equal to sine of C. The inverse of 30 times sine of 70 all over 57.2. That will give us angle C. Angle B is approximately 80 degrees, and angle C is approximately 30 degrees. Let's verify it. 70 plus 80 plus 30 equals 180. Number 6 says to express the vector with initial point 5, 3, and terminal point Q, which is 1 and 0, in component form. So to do that, we have the general formula: x sub 2 minus x sub 1, y sub 2 minus y sub 1. And in this case, the initial point is x sub 1, y sub 1, and the terminal point, Q, is x sub 2, y sub 2. So all we do is substitute. So we have 5, 3, and 1, 0. So V equals 1 minus 5 and 0 minus 3. 1 minus 5 is equal to negative 4, and 0 minus 3 is equal to negative 3. Number 7 says to find the horizontal and vertical components of the vector with given length and direction. So we have a magnitude of V equals 50 and the direction is 40 degrees. So to do this, we want to write a vector of A, B, A being the horizontal component and B being the vertical component. A is equal to the absolute value of the magnitude times cosine of the angle, which is theta, and B equals absolute value of the magnitude times sine of the angle. In this case, 50 is the magnitude. We multiply that times cosine of 40. For the horizontal component, and then for the vertical component, we multiply 50 times sine of 40 degrees. The horizontal component is approximately 38.3, and the vertical component is approximately 32.1.